night is young. Everybody's time will come. Nobody wants to leave alone. Hey there, won't you take me home? I don't wanna lose, but maybe I should.
This is the concept video for the substitution rule. And first I'm going to give a little background on this. So as we've already seen with integration, it's just taking a derivative but backwards. So if we know what function we differentiated to get our integrand, then we'll know what the answer is. So we already know some rules, like the integral of some polynomial is just taking adding a power to the polynomial, dividing by that new power, and you get that result by seeing what happens when you differentiate a polynomial like this. You see that you take away a power, and then, well, first you multiply by that power, and then you take away 1 from the power. So pretty much you use that power rule to derive the rule for the integral. So in a similar way, this substitution rule is the chain rule backwards. So I'll start out by sort of deriving it so we can see where it comes from. If we have a function like f of x equals sine of 3x squared plus 1, we want to find df dx, we'll have to use the chain rule because we have a function sine of x, or the sine function in general, and we have a function inside of it, 3x squared plus 1. So what we do is we set this inside function equal to a u, 3x squared plus u equals 3x squared plus 1, and we make our f of u equals sine u. From there, we simply take the derivative df du, which is simple, it's just cosine u, but we want this in terms of x, so we're going to plug our u back in for x. Oh, inside the cosine, sorry. So df du is cosine 3x squared plus 1. But we want df dx, so if we multiply df du by du dx, these differentials sort of cancel, and we get df dx. So we take our df du, and we need du dx, so we look at our expression for u, and we see that du dx equals 6x. So we multiply cosine 3x squared plus 1 by 6x, and we find df dx. So to integrate something like this, like cosine 3x squared plus 1 times 6x, we'll have to use the substitution rule. So let's start off with g of x equals cosine 3x squared plus 1 times 6x, and we want to find the integral, the indefinite integral of g of x dx. So this is going to be the indefinite integral of cosine 3x squared plus 1 times 6x dx. And what we do is we notice that this is a function within a function, and the inside function's derivative is being multiplied by the whole thing. So it's cases like these where we use the substitution rule. And this is because this function we have here, the integrand, is something that you get from using the chain rule, as we showed up here. So usually when you're presented with a problem, it's going to be like this. you're not going to see any of this. This is just how I generated the example. So the way we go about this is we set this inside function equal to u equals 3x squared plus 1, and then we differentiate du dx equals 3x squared, equals 6x, and if we want to replace this dx, then we'll multiply the dx over, and then we see that 6x dx is equal to du. So we show that we plug in u for 3x squared plus 1, and we plug in du for 6x dx. I'll use some colors to highlight this. Alright, and now this is a simple function to integrate. Integral of cosine u is sine u, and since this is an indefinite integral, we'll put our plus c in there. And we want this in terms of x, so we plug x back in. And that is our answer. So that's a quick explanation of where the chain rule comes from. Where the substitution rule comes from. It's the chain rule backwards, and we use it in cases where we have a function in a function, and the inner function's derivative is multiplied on the outside. We set u equal to the inner function. So maybe I should write this out in some steps. Step 1, identify function within function. Set u equal to the inner function. Find du for substitute, where this rule gets its name, u and du wherever we see it in the integral, here and here. Integrate the simpler function, and then substitute the function of x back in for u. So this is for indefinite integrals. Alright, for definite integrals, the process is actually a little bit easier, and I'll do a quick example with that.
I don't wanna choose, 'cause I could never change it. Feel it on my ears, need you at the door. The sun is in my eyes, we will still be dancing on shaky.
So let's say we wanted to find the integral from, let's make this simple, 1 to 0 of the same function we had before, cosine. Actually, we'll use a slightly different function. We'll use sine 3x squared plus 1 times 6x dx. So here, our first step is to identify. This is a substitution rule problem. We have inner function, outer function, derivative of the inner function. So we can proceed. We set u equal to the inner function, 3x squared plus 1. We find du, and we can write it as du dx for now. Solve for du. Another thing you might want to do is solve for dx, if that's easier for you. Both strategies work. Sometimes one is more useful than the other. We set dx equal to du divided by 6x. This is usually better if the constant doesn't match here or something, and we'll do it that way. We'll put in this right here, and we'll put in our u right here. So our integral, this equals, oh sorry, I forgot one important step. So we have to change these limits. These limits are in terms of x. This is x equals 1 and x equals 0. So since we're changing this to a function of u, we're going to change the limits to u limits. So better way to write this u out is u of x, and I'll put this back in here. So we want to find u when x equals 1 and u when x equals 0, and these will be our new limits. So 3x squared plus 1 when x is 1, well, 1 squared is just 1, 3 plus 1 is 4, 0 squared is 0, and 0 plus 1 is 1. So our new integral is the integral from 4 to 1 of sine u, and we still have a 6x here because we're going to replace the dx with du over 6x. So this is our dx piece. This is the u that we found. And what happens here is 6x's cancel, and we're left with the integral from 4 to 1 of sine u du. Integral of sine is negative cosine. And since we have u limits here, I should clearly put that u equals 4, u equals 1. You don't need to do this, but sometimes it helps to know. Since we have u limits and we're evaluating a function of u, we don't need to plug 3x squared plus 1 back into here. We can just evaluate negative cosine of 4 minus the negative cosine of 1, and we get an answer. These minuses will cancel, of cosine 1 minus cosine 4. That is our answer. So we can do steps for definite integrals. And step 1 will be the same, identify function within function. Step 2 should be the same, set u of x equal to inner function 3, find du 4, and this is a step only for definite integrals. Change x limits to u limits by plugging x limits in to u of x. 5. It's the same. Substitute u, du, and limits. So that's a little bit different, so I'll put a star next to it. Integrate simpler function 7, and instead of substituting the function of x back in for definite integrals, evaluate the final function at u limits. Don't put some caps there. Don't substitute the x's back in. Sorry about this. So that is our steps for definite integrals. A little bit different than indefinite. They're a little bit easier since we don't need to plug back in, but sometimes evaluating can be difficult. So I'll go back up to the indefinite integral steps. And I think the steps are really the most, it's recognition and the steps that are most important, in my opinion. So we'll do some examples next to nail this process down. Thanks for watching.